Hello everyone, today we are going through multiplication theorem on probability. It's very important topic. Multiplication theorem on probability, it helps to calculate the probability of multi-events occurring together. Okay, that is for events A and B, this theorem states that probability of both events A and B occurring together is probability of A and B, that is equal to probability of A intersection B. Okay, probability of A and B. We know that and refers to the intersection, right? So here probability of A intersection B. Here A intersection B indicates that the event that both A and B have occurred. Okay, so probability of A intersection B, that can be written as probability of A into probability of B. Okay, so here this case is only for independent events. That is, if A and B are independent events, then probability of A intersection B is equal to probability of A into probability of B. Then for dependent events, probability of A intersection B is equal to probability of A into probability of B given A. See, this will get from our conditional probability formula, that is probability of B given A is equal to probability of B intersection A divided by probability of A, right? So take this one here, you will get the same, right? So if two events A and B are dependent events, then probability of A intersection B is equal to probability of A into probability of B given A. Let's take an example so that you will understand the concept very quickly. Okay. So here, example, a bag contains 6 white balls, 5 red balls and 4 black balls. Okay. And 3 balls are drawn at random without replacement. Okay. Without replacement. Now, what is the probability of 3 black balls are drawn? Okay, what is the probability of 3 black balls are drawn? So here 3 black balls, right? Sorry, probability of 3 black balls. Okay, now there are total 4 black balls, right? So here probability of 3 black balls, that is equal to, see, let's name it as B1, B2, B3, B4. Okay, so first we select one ball. Okay, so what is the probability of first ball? That is, there are total 4 balls. Okay, so 4 divided by total 4 black balls. Okay, and divided by how many total balls are there? 15, right? So 4 by 15. That is the probability of first ball. Okay, and here we don't replace it back. Okay, without a replacement. Now one ball is reduced in the bag. Okay, and if it is black ball, then one ball is reduced in black ball, right? So next there are total 14 balls and only 3 black balls. Okay, therefore what is the probability of next ball? So next we select another ball. Okay, so that is what is the probability of that black ball? So here one ball is reduced, therefore 3 divided by 14. Okay, now 2 balls are reduced, right? Because it is without replacement. So 2 balls are reduced. So for next ball, so next event, that is probability of another ball, that is third black ball, is 2 divided by 30. Okay, because again one ball is reduced. See here, this third event is depending on these previous 2 events, right? And this second event is depending on first event, right? Therefore, such events are called dependent events. Okay, so here dependent events. Okay, so in this case, how to find the probability? So probability of B1, B2, B3, because here we have to find the probability of 3 black balls are drawn, right? So probability of B1, B2, B3 is equal to 4 by 15, that is probability of B1, okay, into here it is probability of B2. See, here we are selecting from this one, right? That is, this B1 has already occurred. Okay, that event B1 has already occurred. Therefore, next is probability of B2 given B1. Okay, probability of B2 given that B1, because here B1 has already occurred. Okay, next probability of B3 given B1 and B2, that can be written as B1 intersection B2. Okay, B1 and B2, because this third event is depending on these two events. Okay, these two previous events, right? Therefore, it is probability of B2 given B1 intersection B2. So, therefore, probability of 3 black balls are drawn is equal to probability of B1 into probability of B2 given B1 into probability of B2 given B1 intersection B2. This is for dependent events. Okay, this case is for dependent events, that is without replacement. So, next, let's take same example. A bag contains 6 white balls, 5 red balls, 4 black balls. Okay, here also 3 balls are drawn at random with replacement. Okay, here with replacement. Okay, now what is the probability of, same question, probability of 3 black balls are drawn. So, probability of 3 black balls are drawn, that is equal to, see here, first we select one ball. So, what is the probability? That is black ball. Okay. So, what is the probability? 4 divided by 50. Right. Now, again replacing it back. Okay. Replacing it back. And what is the number of balls? That is same. Right. Remaining same. Number of balls in the bag remaining same. That is 15 balls. And there are 4 black balls. Because with the replacement. It is the experiment with the replacement. Okay. Therefore, in second case, what is the probability? Second ball, second black ball. Same thing, that is 4 by 50. Okay, because we have replaced what we have selected. Right? So, next is third. What is the probability of third ball? Third black ball. That is also 4 by 50. Right? So, here, see, this second event is not depending on first event, and third event is not depending on these previous events, right? So, such events are called independent events. Okay, so independent events. So, in this case, we can write it as probability of 3 black balls are drawn, that is equal to, if it is B1, B2, B3, then probability of B1 into probability of B2 into probability of B3, because in all these cases, we are selecting from the previous one. Okay, that is, here it is not depending. Okay, so these are independent events. Therefore, probability of B1, B2, B3 is equal to probability of B1, probability of B2 into probability of B3. I hope you understood this concept. Okay, now let's see, if there are n events, then what is the multiplication rule of probability? See, if these events are dependent events, that is A1, A2, A3, etc., An are dependent events, then probability of A1, A2, A3, etc., An, or you can write A1 intersection, A2 intersection, etc., intersection An, that is equal to probability of A1 into probability of A2 given A1 into probability of A3 given A1 intersection A2 into probability of A4 given A1 intersection A2 intersection A3, etc. probability of An given A1 intersection A2, etc. intersection An minus 1. Okay. So, if A1, A2, etc. An are dependent events, then probability of A1, A2, A3, etc. An is equal to probability of A1 into probability of A2 given A1. Okay, for dependent events. And next, probability of A3 given A1 intersection A2. Probability of A4 given A1 intersection A2 intersection A3, etc. Probability of An given A1 intersection A2 intersection, etc. intersection An minus 1. Okay. Next, for independent events, here also let's take let A1, A2, etc. An be the n events and they are independent. Okay. Then probability of A1, A2, etc. An, that is equal to probability of A1 into probability of A2, etc. probability of An. Very simple, right? So for independent events, probability of A1 intersection, A2 intersection, etc. intersection An, that is equal to probability of A1 into probability of A2 into etc. into probability of A. Okay. So it is the multiplication rule of probability.